Thank you so much for your love and support. And once again, we are back with another video tutorial. And this video tutorial is regarding pod lifecycle. So to understand pod lifecycle, we just take a little analogy of a kitchen. So imagine you wake up hungry one morning and you decided to cook yourself something nice. Let's say noodles. So what is the first step? That's checking the ingredients. You need to head to the kitchen and start checking your ingredient. So you find that garlic is there, coriander is there, chilies are there. So everything is there, but tomatoes are not there. So before you cook, you need to buy tomatoes from the stores. So in pod analogy, when you start a pod, it first enters into the pending state. And Kubernetes checks if there are a space in the pod, there are network resources available, there are means everything it checks. We'll discuss what it checks. Like something container images are not there, so images it fetches. But if some resources are not available, then pod always be in a pending state. So let's take an example. So here I will make a pod and there is no space available, means no CPU available for the pods. So let's get started with little demo. So here we are in Killer Coda. So here first I will check K8S nodes. So here two nodes are present, node 1 and control plane. So I will check describe the node 01. K describe node 01. So I'll just go up little here. So many things are here. Skip everything for right now for the time being. And here you will see that these are the current state which is utilized. So 125 M means when one CPU equal to 1000 M. So here 125 M. So still 875 left. So we utilize 875 by creating some pod. Just this is not a part of our. So for that I will go to the kubernetes.io. Here I will search request. So I'll just copy this resource file. I will create a pod file YAML. I'll paste it here. So it will not confuse us. So I will take it in new and this is not required. Limit is not required. Request will keep 875 or 870 and memory will keep it. It's okay. Whatever you will take, no issue. So I'll delete rest of it. Don't worry if you won't understand anything. Just we are making something that I had played. So 5 CPU. This only 5 will left for next pod to use. So K apply -f pod. I'll make pod utilize and okay. K8S and Neo. So pod is created. So now we'll describe node 01. And now if we check, you will find why it is showing pending state. Insufficient CPU. Why? Oh, we forget to write M. Sorry guys. But this is also a case of pending state. The pod is in pending state. So I'll delete that pod again. Delete pod and Neo. I'll create a pod. So pod is created. Now we'll check get pods -and Neo. This is just a naming space. So pod is running. So now if you will describe describe pod describe node 01. So you will see that this is 995. If I will make a pod of 10 milli CPU also, then that pod will be in pending state because only 5 M is left. How I understand 5 M is left because here CPU allocatable is 1 and these are the maximum we can allocate. So Control L and now I will write tmux and Control B %, Control B left arrow and I'll make another pod. Means I will edit that pod YAML file and I will name it something else, pod pending demo. Okay. Now here I will remove namespace and here instead of so this much, I'll just keep it 10 or 20, let's say, and memory is okay. So WQ and say. First I will do Control B and this K8 pod -w. So whatever pods are in default namespace, it is showing because I had not put any namespace there. Control B minus. So now I will just create a pod and you will see here. You will see here I will create a pod and the running status will show here. So I'll K apply -f pod. So look, this pod goes into the pending states. If I will delete pod -n neo, so you'll see that pod goes into the container creating state and then it will start running, because means we had make that whatever the reserved thing go away, means that is free for any resource. So I'll k describe node 01. So you will see there. So here you will see that resource is now only 14% occupied. So here this pod goes to the container creating state and then in the running state. So the pending state is clear, means we don't have any resources, then we cannot proceed for the creation of whatever. If it is the cooking or it is the pod creation, both are behave like a same. So again, we have seen that container creating state in demo and running state also. So when you are back from the store and now you have ingredient, so you begin to preparing. You washed and chopped tomatoes and garlic and boil water and you pan ready on the stove. You are not cooking yet, just preparing everything to start. Similarly, in a Kubernetes setup, everything for your pod need to start running. This phase is a container creating and it mounts volume, checks up networks and create containers, but hasn't started the process yet. So, and running. Everything is ready. You start cooking tomatoes, garlic and sizzling in the pan, and that noodles is boiling nicely.
Almost
and
done.
kitchen smells great. You
This
are
pasta
actively
looks
cooking your dish
perfect.
and it's going to
I'm
be
gonna turn off the
perfect.
stove now.
So if we do it as a pod analogy, then the pod moves into the running state and the container inside are actively doing their work. So like serving web request and processing data and running your applications. So the pods come is in ready state. Why I'm making this video is a little time consuming, because you will always see pod. You will always and always you will get pod with certain namespace and you will see the status. It is running, it is crash loopback error, whatever. Well, we will see that also, crash with loopback error and whatever the image error and whatever error, that pod is not getting ready. So the step 4 is succeeded. So meal is ready, means your noodles is ready, means you take off the stove on the plate and happily enjoy your meal. You are done cooking and outcome was successful. So in pod analogy, for the pod designed to platform or a single job, like running a script or a batch process, once their task is completed successfully, they enter in a state called succeeded. So application like a web server rather than a job or a task designed to complete quickly. Only pod running tasks that naturally finish, like jobs or short running container, transition into the succeeded or completed state. Regular applications like Nginx web server typically stay in the running state. So most of the time you will see that running state, but few, when you install Calico or something, you will see few pods are in completed state. So let's quick have a demo. Once again, we'll see when the pod goes into the pending, running, pending, container creating and running state. So I will tmux Control L. I will tmux so that I will have parallel screens. Control B and %. So vertically the screen will be splitted in two. Now Control B and left arrow will go into the first screen. Then K get pods. So here pod is already running. I will delete this pod. K delete pod and pod. Here I had not mentioned the namespace because it is created in the default namespace. We'll dig into the namespace concept later on, but for the time being, it's like abstraction or it's like another room. So I already have a pod manifest file here. So now I will name it pending, container creating and then running. So I'll wq. So Control B right arrow, K get pod -w. Now Control B, I'll create that pod and you will see in the right screen K apply -f pod So here you will see that pod goes into the pending state, then pod goes into the container creating state, and then pod goes into the running state. So all the concept we have discussed is proved here. Now we'll go into the completed, means this is the status you will always find, because so I'll exit this tmux session, and now I'll press Ctrl L, and now we'll just have a demo of succeeded ones. So kubectl run test succeeded image equal to busybox, and here one properties of pod, that restart or not. So this complete and succeeded will come when the restart policy is mentioned. fn sleep equal to 5 seconds. So I'll make this hash. I also want to see this in parallel session. A get pod -w. Here also already delete pod pending. So and a get pod and control B now. So I will just enter, and you will see right side. So pod goes into the pending state, and then pod goes into the run container creating state, and then pod create into the running state. And after 5 seconds, you will see that it's a 4 second. Oh, sorry, it is not here. I'm not able to. Yes, it's a 4 second. It's a 9 second, because we have given a sleep of 5 second. So after the 5 second task is completed, and this goes into the completed state, means my task is completed, my noodles is completed, and I had no task. So the chef can go home, means it's a completed. So this is, you will see completed state in if the pod existed with the succeed, means it's a exit code 0. So where do you see exit code 0? So you just kubectl describe pod test succeeded, and then grep, and then I'll write I, so case sensitive also, and then E4 means up and down both side 4 lines, and exit something, right? I will just check test succeed. So here test succeed, control B, exit code. Here is the exit code 0. A describe pod test succeeded grep. This is the exit code 0. So you will see that exit code is 0. And more thing, if you want to see that, I'll press A4. Sorry. Oh, where I'm putting this? Sorry. So I forgot something, that is -A4. So here you will see, and I'll make it E. So here you will see reason is completed, and that exit code is 0. Exit, we understand the succeeded state. So your pod didn't reach succeeded because it never completed naturally. So here we use grep command, and command is very powerful, and in Linux onwards we'll use it much. So in next video we'll discuss grep command, and so that you won't be surprised where I have put -I, -A4, E4 like things. So using short-lived task or a job as shown here, demonstrate the succeeded or completed pod lifecycle. Now, fifth stage is like a failed. So if suppose cooking goes wrong, but sometimes things go wrong, maybe you forgot to pan or stove, got distracted, and means something is burned, you can't eat that meal, it's ruined. So in pod analogy, if Kubernetes, if something unexpected happen, like your application crashes or error occur, the pod goes into the state called failed, means it could not finish properly. To see a pod in the failed state, you need intentionally make your pod fail. So I am here making some mistakes intentionally so that pod fails. So here I will go, and same, I will delete this pod. So what I will make that instead of, so here I mentioned fail. So what Linux do, it immediately return 1, means with the exit code 1. So exit code 0 is a successful, but exit code 1 is not successful. So before running, I will go in second screen and K8 pods -w control B. So you will see here steps. Error means your pod failed to run successfully. So if you describe same means if you describe that with a grep command, so here you will see exit code 1 means there is a failure. So in summary means running a command like false deliberately creates a failing pod, but if that pod exit with a non-zero exit code, then it's a clearly failed state, and you will see that there. And the sixth step is like a crash loopback off means repeated failures. So imagine you try again but keep make same mistake after several steps. After several time by doing the same mistake, you decided to pause it and step away and figure out what's wrong before you trying again. So pod analogy: simple Kubernetes pods sometimes repeatedly fail and restart after multiple quick failures. Kubernetes pause restart temporarily, and this condition is known as crash loopback off, and it gives you time to find a problem. We need to make a scenario of failed crash loopback error, failed crash loopback off. So here instead of, I'll just delete delete pod failed pod. Here I have changed that restart policies. So -w, and so you will see that pending container error, and you will see that crash loopback off is there. And after this crash loopback error, this will increase exponentially. Means here you will see it's a 4 second. After the second restart, it would be much. It's a 18 second, and after that you will see that it's exponentially increasing the time. So the Kubernetes detected a repeated failure, and pause means temporarily. By intentionally using continuous failing commands with automatic restart, your pod switches to Kubernetes back off. Now there is one more part of life cycle, that is the terminating. So what does terminating means? Means after enjoying your meal or deciding you are done cooking, you clean up, you wash dishes, pan and utensils, and tied up your kitchen. You are actively cleaning up your workspace. Pod, in terms of pod analogy, you decided to delete a pod. Kubernetes put it in terminating state, and there it cleans up container, remove resources, and gracefully shut down everything. Shut down that pod. So just will delete this pod. So here always also you see terminating. Okay. So I'll create a pod. Oh shit. No issue. We already have get pod -w. So pod is running. Now I will delete that pod, and you will see that it terminating steps here. So here you will see terminating. So that termination steps is there, and here you will also say completed means kitchen is clean and everything is back in place. So I'll wrap up here. Already this stretched so much. So we'll try to make if things are left, I will make a separate video again, and there will explain whatever the left topics is. Thank you so much for your love and support, and provide the feedback. And in next topic you will see grep command and whatever the Linux command we use till date means from when we started our Kubernetes 2025 course. So that will be helpful, and whenever we use some new commands, we'll attach a separate video for that, so that if you are not aware of that command, you can quickly go through it. But YouTube is always there for learn the things. Thank you so much for your love and support.